So friends, in this video we are going to discuss about the projectile motion, and this is the term, this is the formula I'll be using, which is just the nature. This is a projectile launched with the velocity v and at an angle theta. So the important factors is that it has the horizontal distance that it will be covering, which is given by the formula r equal to v square sine 2 theta upon g, and then the maximum height that the projectile will attain will be h equal to v square sine square theta upon 2g, and the time of flight is t capital T equals to 2v sine theta upon g. So these are three formulas I'll be using. These are the mathematical explanation that at each and every moment it has the two component, one along x-axis horizontal component, one along y-axis that is vertical component, and the resultant of these two will be along the tangent at that point, and that will determine the resultant velocity. Now here also, while falling, you can have one horizontal component vx, one vertical component, and there is the resultant. This is the theme of our application you have already seen. So here I just try to explain you that here in this program I have created a class projectile, and it has two parameters v and theta. So self dot v equal to v and self dot theta equal to theta. Now I have created three functions: range, time of flight, and the maximum height. Range will calculate the horizontal range covered by the projectile and the projectile. So the formula I'll be using there, the range is v square. So v square sine 2 theta upon 9.8 is v square sine 2 theta upon g. Time of flight is 2v sine theta upon g, and the maximum height is v square sine square theta v square sine square theta upon g, and the value of small g, acceleration due to gravity, is 9.81 on the surface of earth. This is v sine, this is, you can say this is sine theta and this is sine theta. So sine theta into sine theta will be sine square theta. Self dot v into self dot d is v square. So v square sine square theta divided by 9.81. So it is 2g, that's why I'll write 2 into 9.81. The formula I have already discussed at the beginning. You can halt the screen there, you can write the formula somewhere. Now you can see. So now I accept the velocity and the angle from the user, since these sine functions, cosine functions take the radian values, and the user normally are more comfortable with the angles expressed in degrees. So better I will ask the user to enter the angle of projectile in degrees, and then I will convert this into radian by using the formula that degree value into pi upon 180. So ango is the variable which contains the degree values. So ango equal to ango into, so this is angle short form, so ango into math dot pi and divide by 180. So the same value, the same container, the ango was the container which was containing the degree value. Now it is the same container, it will contain the radian value. So I'll create the object of projectile as pr1. I can make it proj1, and then with the help I'll pass the value v and ango, and then I'm calling these three functions and printing them in three different lines. So let me just make it proj1, projectile1, prog1. So here also prog1, prog1. So here also it's underlined ones, they're becoming red, so I need to make changes. This is prog1, prog1, and then I'm calling the range function, I'm calling the time of flight function, I'm calling this vertical functions. So everything now looks cool. So this is, again, I'm accepting the velocities and the angle of launch in degrees, converting into the radian values, and then I'm creating the object and passing these three values. So these values comes here, v and theta. So v goes in self dot v and theta goes in self dot this, and then this formula is v square sine 2 theta upon g, and the next one is 2v sine theta upon g, 2v sine theta upon g. Sine theta is written as math dot sine dot self dot theta upon g, and this is v square sine square theta upon 2g. So everything now looks perfect. Now let me run the code and see how it works. So since those who have studied physics, they know the projectile motion, and now just to see how it works actually. So here I go, and now I run the code and see that enter the launch velocity. So I'll be launching 12 meter per second, and the angle is 45. So this is the value. Horizontal range 14.6788, and then time of flight is roughly 1.72 seconds it is. And then I change the launch velocity to something else, some bigger value. So now here I just try to rerun the code with another set of values. So the launch velocity is 50 meter per second, and the angle is let me write 90. So it will go vertically upward. So logically horizontal distance r should be 0, but now you see the program is showing that it is 3.12 meter and it's 10 to the power minus 14. So this is very close to 0, but it is a value. You cannot say it is just dropping at the same point, like 3.120, and e minus 4 is 10 to the power minus 14. Means this is just kind of thinnest, like the hairline structure, but you can say it is not 0. So this is the real difference between the computer and the mathematics, because mathematics is the exact science and the computer have some approximation, because every computer have the, now here I said angle of flight is 0, so horizontal range is 0, time of flight is fine, because when you're making theta is 0, so the angle time of flight will be 0 and the maximum height will also be 0. So these are the limitations of the programming language or the platform, or the limitations of the machine, but physics is doing its job perfectly. So now take one more value just to understand what possible values it can provide. This is the final shot, and then I'll take the launch velocity something maybe 40 meter per second, and the angle of projectile, like the angle at which it is released, is 56. And now this is what. So subscribe to our channel and keep growing, and just comment also, because we have worked hard to make this video. I do not know how it looks and how do you appreciate. So your word will be a very sense of appreciation.